Okay, so we're going to start talking about quadrilaterals today. And just as a refresher, quadrilaterals are four-sided figures. What we had talked about before was polygons, and polygons is just any closed figure with straight sides. And so you could have three-sided, four-sided, five-sided, six-sided, seven-sided, and so on. And so now we're going to kind of focus in on some special four-sided figures. So today we're just going to talk about parallelogram and their properties. So the first one, let's talk about the opposite sides. What kind of properties do they have? So they have that opposite sides are congruent. They also have that the opposite sides are parallel to each other. Okay. So now from this diagram, if you have 3 points and you got to figure out the fourth point, well, we know that opposite sides are congruent, so let's make them congruent. So these are 1, 2, 3, 4 spots apart. So let's make 2, 3, 4 also 4 spots apart. So the fourth point would have to be there. And then we can go ahead and connect all of our points to make our parallelogram. So now we've got the 4 points. So now we know that the opposite sides are congruent, and then the opposite sides are parallel. So we know the top and the bottom are parallel because they have the same slope. And remember, if they're parallel, they have the same slope. So both of those have slopes of 0. And if you look at the left and the right side, they both have a slope of 2 over 2, up 2, right 2, which is the slope of 1. So they both have the same slope. So therefore, we know that opposite sides are congruent, opposite sides are parallel. So if we had to mark them, remember, we mark like this, and they wouldn't all be marked the same because they're not all congruent, just opposite sides are congruent. Now to mark parallel, remember we use arrows. So the left and the right side, which are opposites, are parallel to each other, and the top and the bottom are parallel to each other, which use a different number of arrows. Okay. So our next set of properties talk about opposite angles. And in this case, opposite angles are congruent to each other. So again, we have our 3 points, and we want to figure out, well, what is the fourth point? And so we can still do that by counting the distance here. So we got 1, 2, 3, 4 here. So 1, 2, 3, 4. Now, if we have more space on the other side, we could do 4 spaces to the left, but that's out of our graph. So those are our 4 spots. So that's our fourth point there. And then we can connect them to make our parallelogram. Okay. And so what this talks about is opposite angles are congruent. So opposite angles are the angles that are diagonal from each other. So those 2 angles are congruent, and these 2 angles are congruent to each other. The ones that are across from each other, opposite from each other, are congruent to each other. And then our next property is about consecutive angles. And consecutive angles are supplementary. And just as a refresher, that supplementary means they add up to 180 degrees. So again, here we have 3 points, and we want to find the fourth. So this one has 4 spaces in between it. So here we're going to have 4 spaces in between it. So our fourth point is going to be there. So I can erase the loops. And then we're just going to connect them. And we're going to pretend I drew straight lines. Okay, so there's our parallelogram. And so when they say consecutive angles are supplementary, let me make sure you can understand which angles are consecutive. So I'm just going to label these angles 1, 2, 3, and 4. So for consecutive angles to be supplementary, angle 1 plus angle 2 should add up to 180 degrees. So angle 1 and 2 are consecutive angles. But also angle 1 plus angle 4 equal 180 degrees because both of those are also consecutive. And then angle 2 plus angle 3 have to add up to 180 degrees. So 2 and 3 would be consecutive. And then angle 3 plus angle 4 have to add up to 180 degrees as well, because those are also consecutive. So just kind of making sure consecutive is not the one that's across from it. It's kind of, if I kept going around the parallelogram, the next one I would hit. Okay, so that's about the consecutive angles. And then the last properties have to deal with the diagonals. So the diagonals in a parallelogram, they bisect each other. And so remember, bisecting means they cut each other in half. So one diagonal cuts the other one in half. And then we just need to make note that diagonals do not have to be congruent to each other. They can be, but they do not have to be. All we know is that they bisect each other. So again, here we have 3 points and we want to find the fourth. So this one, 1, 2, 3, 4, 5 spaces. So let's move this one, 1, 2, 3, 4, 5 spaces here. So there's our fourth point, and then we can connect and make our parallelogram. Okay. And then so let's go ahead and draw our diagonals in. So our diagonals go from here, and then here's our other diagonal. Now, as we can see, those two diagonals are not the same length. Like we said, they don't have to be congruent, but what we do know is that they bisect each other. So they cut each other in half, but it doesn't mean that they have to be equal. And this point where they intersect will be the midpoint of either line. So it's the midpoint of either diagonal. Okay. So what shapes are in the parallelogram family? So we know parallelograms are just a special type of quadrilateral. So I could have a bigger circle around all of this that says quadrilateral, and parallelograms are just in there. But inside of the parallelogram circle, we have some subcircles, which are rectangles, squares, and rhombus. And you see the squares where the rectangle and rhombus overlap, and we're going to talk more about that later. Okay, so rectangle, square, and rhombus are parts of the parallelogram family. All right, so now what shapes are not part of the parallelogram family? So we start and we have quadrilaterals just on the outside as the big circle, and we have a section for parallelograms, but we also have a section for trapezoids, and as we can see, they don't overlap, so they don't have anything in common. Inside that parallelogram circle would be the rectangles, the rhombus, and the square, but we see those are totally in the parallelogram and they don't overlap to the trapezoid. Okay? And so that's it. Go ahead and put this, make sure this is in your notebooks.